Today we are going to have a discussion on nuclear chemistry. We will work out few important problems based on the nuclear reactions and nuclear properties. One of the important properties of the nucleus, radioactive nucleus or a nucleus, is to exhibit radioactivity. Not that all the nuclei will exhibit radioactivity. There are some nuclei which will be radioactive. So there is the radioactivity, as we have discussed earlier, consists of the emission of alpha, beta and gamma particles. There is a law relating to the radioactive properties. That law is known as Russell-Soddy displacement law. What is that law? State that law. The law one, there are actually three important laws. One law says when a radioactive species emits an alpha particle, if there is a loss of an alpha particle, that is, alpha particle is actually, as we know, is a helium nucleus. So when it loses the mass by about 4 units and loses a charge by about 2 units, as a result the element is shifted to 2 positions towards the left. This is the first law. 2 positions towards the left, and in terms of mass it goes back by 4 atomic mass units. A very simple unit, a very simple example of the loss of an alpha particle, that is the first law. The first law says if on account of the loss of an alpha particle, alpha particle emission leads to an element which is 2 positions to the left of the original position, and in terms of mass it is 4 positions behind. So a typical example of this will be given as for example, a typical example of this will be given as uranium 92 of mass 238 loses an alpha particle to give rise to thorium 90 of mass 234 and an alpha particle. This is the example of, this is the first law, which is known as Russell-Soddy displacement law. The first law says when an alpha particle is lost, the position of the element moves to the left by 2 units. The second law says, the second law is related to a beta particle emission, law 2. There are actually 3 laws. When a beta particle is lost, from a radioactive species, there is no change in the mass because the beta particle is equivalent to an electron. Therefore, there is no change in the mass, but it moves to 1 position to the right. So the loss of a beta particle can be given as a C14 nucleus losing N14, losing an electron, giving rise to, the mass remains the same, but the charge goes up by 1 unit, and of course an electron is lost, or this is equivalent to a beta particle or an electron. So this is a second law. So the first law is loss of helium going behind by about 2 units in atomic number and 4 units in atomic mass. And in the case of the loss of the beta particle, the position of the element goes to the right by 1 unit, but there is no change in the mass. As far as the law 3 is concerned, there is no change, there is only gamma radiation. The gamma radiation is just nothing but electromagnetic radiation or light rays of very high energy. Therefore, there is no change in the mass, there is no change in the position of the element. Only thing is, a lot of energy changes are occurring during a gamma radiation process.